Hello, my friends. I'm Clover, and this is Genuinely Approachable Sudoku. And today we are solving a classic Sudoku by Philip Newman called Thermo on the Brain. This was originally posted on February 6th, 2025, and it is a classic Sudoku, meaning that we just have standard Sudoku rules to contend with today. So we're placing the digits 1 through 9, once each, in each row, each column, and each outlined 3x3 region. So let's have a look at this. I actually did not get a chance to solve this when this was originally in testing, so this is a blind solve from me. The first thing I've noticed here, and this maybe isn't the very first thing Philip wanted me to notice, but it's what jumped out at me right away, is these 2-3 pairs that are all looking into region 2. Those eliminate the digits 2 and 3 from these cells, obviously these cells and these cells, so that's going to make these two cells 2 and 3. Because there's already a 3 in this row, that's going to be my 2, and that is going to be my 3. I'm curious, this is a Philip puzzle, they're often highly symmetrical. If there is a symmetrical deduction to be made down here at the bottom, it looks like I've got, yeah, exactly, 7s and 8s here, looking into this region. It tells me that these two digits have to be 7 and 8, because there's nowhere else to put 7/8 in region 8, so that's going to be my 8, and that is going to be my 7. Now, those regions are getting fairly full, so let's see if we can do more with those while we're here. So the remaining digits we need here are 1, 4, 5, and 6. 5s can't be in those cells. This can't be a 4 or 6 because those are in the row already. And this can't be a 1 or 4 because those are already in my row there. Alright, so that doesn't seem like that's yielding anything really useful right away, so I'm going to set that aside, and I'm probably going to come back to that shortly. Let's see what else we can do to get some digits here. So, I'm noticing 5 is kind of restricted in this corner region, but not like fully restricted. It's also correspondingly kind of restricted down here, but like not quite fully. 8 down here in the bottom right only has one position. I've got an 8 there, so I can place an 8 here, and correspondingly I have a 2 up here in the top left that only has one possible position. In this row, I'm still going to need 1, 5, 8, and 9. And this cell is going to be a naked 5 because I've already got 1, 8, and 9 in the column. So that's going to be a 5. That'll make that a 1. And that makes this an 8, 9 pair that, unless I'm totally missing something, I can't quite resolve yet. So that takes that column to the point of being a little more restricted. I need 3, 4, and 7, and this cell can't be 4 or 7, so that's a 3. This can't be a 7, so my 7's there and my 4 is there. So let's do something similar across this bottom row because this puzzle does appear to be symmetrical. So in this row, I still need 1, 2, 5, and 9. These can't be 9. That can't be 1 or 2. That can't be a 5. This can't be a 5. That can't be 1 or 2. I know I did that in kind of a sloppy order, but we did arrive at the conclusion in the end that just like the 5 up here, we also have a naked single 5 down here. That makes this a 9. I can eliminate 9 right here. And then we're going to address this column. I still need 3, 6, and 7 vertically in this column, and because I have a 3 and 6 in the region, that'll be my 7. I need a 3 there and a 6 there. Now I have 2 3s there and there looking into this region, and a 3 right here. So the only position for 3 in region 6 is right there. And I also have these 2 7s. Combined with this 7, the only position for 7 in this region is in that spot. Now, in this region, I still need 4, 5, 8, and 9. Those can't be 4. These can't be 8 or 9. I can't have a 5 in any of these cells because I have a 5 right there. That's not an 8. Here I need 1, 4, 5, and 6. That can't be 4 or 5. That can't be 1. Oh, these also can't be 1s. Okay, so I just placed a 1 up here. So let's take a little detour and place this 5 right here. And take a look at this column. So we need a 4 and a 6 in the column. In this region, I do still need a 5. It can only go there because of the 5 here, so that's going to be a 4 or 6. And now that tells me in this central region, the only positions for 4 and 6 are here and here, so I'm going to make that a 4, 6 pair, and then these are going to be 1, 5, 9, and I'll eliminate 1 there because of the 1 right there. So that's as cleaned up as that's going to get for right now. Here I need 2, 3, and 4 to finish the row. And because I already have a 2 and 3 in this column, that will have to be my 4. That's a naked single 4. This 8, 9 pair now gives me a 4, and that's going to resolve my 4s and 6s. And I get a little more classic Sudoku out of this. That's going to be a 5 or 9. The 8, 9 pair makes this a 5, and this is now a 9. Over here, I'm going to have a 1, 2 pair. Here I need 1, 2, and 9 to finish the region, and because I have a 1 and 9 there, that'll be a 2. They're really just a lot of, not really challenging to spot naked singles, but this puzzle, at least how I'm approaching it, is very centered on naked singles as opposed to hiddens. So now I'm just applying a little bit of classic Sudoku to resolve some of my last couple of pencil marks. And here my last digit will be a 3. Here my last digit is a 1. Here my last digit in the row is a 9. Oh, that's not a 3. Okay, I said 3. The last digit I actually need here is going to be a 6. I actually had a 3 right above that. That's probably what I was reading. Here I need a 1. I need a 9 in this row. And here I'm going to need a 7. And that is how you solve Philip Newman's Thermo on the Brain. I suspect that the reason it's called Thermo on the Brain is because I happened to catch Philip talking on Discord about his recent return to the problem of finding minimal thermo-variant Sudoku. So keep an eye out for other thermo-adjacent puzzles. I'm not sure kind of what the relationship between this classic Sudoku and that problem is, but keep an eye out for more thermos from Philip in coming days. If you want to solve this one yourself, the link to do so is in the description below this video, and I will see you again in a couple days.